So we are going to be continuing with our collisions kinds of questions that we've got here. But the only difference about these ones compared to the ones that we've done before is that everything is going to be algebraic. You can see that it's algebraic in the sense that during the question they're talking about the mass as 3m and 4m. They're also talking about the speeds as 2u and 3u, meaning that everything throughout the question is going to have some unknowns in as well. Actually, you'll also see in this question there's an extra unknown, which is the coefficient of restitution as e. So there's a lot of unknowns that will be happening here, but we know from what we've done previously that it's going to just be those two things that you can do for a collisions question. What are the two things that you can do? Good. PCLM, which is the principle of conservation of linear momentum, and NLR is Newton's law of restitution. So let's actually read through this and see what's happening. Two small spheres P and Q have masses 3m and 4m respectively. They are moving towards each other in opposite directions on a smooth horizontal plane. P has speed 3u and Q has speed 2u just before the impact. The coefficient of restitution between P and Q is e. Show that the speed of Q after the collision is u over 7 brackets 15e plus 1. You'll see that this is a really common type of question that we'll be coming across, and actually the speed always seems to take this kind of format where there's like some kind of fractional u at the beginning, or maybe just a u at the beginning, and then inside the brackets there's always something to do with e and a kind of constant. So for this first example, it actually is going to take a model of what most of the things are going to look like. Your speeds are going to be of this general kind of form where you have some kind of fractional term of u at the beginning and then a mixture of e and a constant coming afterwards. Okay, so we're going to just draw out our starting diagram. They told us that the masses of P and Q respectively were 3m and 4m, and that they are moving towards each other in opposite directions. P has a speed of 3u and Q has a speed of 2u. So this whole question is actually talking about, it's just saying there are two particles that have their ratio of the masses are 3 to 4. It could be 300 kilograms and 400 kilograms, or it could be 3 grams and 4 grams. As long as they're in that same ratio, then this should be true. And it's the same with the speed, that this one is going 3 times some speed and this one is going 2 times some other speed. So we're trying to make these scenarios as general as possible. Right, the other things I guess we need to put on here are the speeds afterwards. Notice how I've put them both going in the same direction. It's just the way that I think it's going to be sensible if we do that as a whole class, just to always do them going in that direction, unless the question that we've got written at the top tells us something about it, unless it says P's direction is reversed or something like that. I use X and Y. If you look in mark schemes, you might see V1, V2, you might see V, W, X, Y, Z, all of those kinds of letters. I probably use X and Y the most because we're just most familiar with using that, and it sort of seems a little bit easier to do. Okay, so we're actually just going to go through that same sort of process that you've been doing in your homework questions. Should we start off doing PCLM? PCLM. So what should the first line of PCLM be for this? Arifa, what would PCLM be for our scenario that we've got here? Good. Good that you've done the minus 2u. And what's that equal to? 9mu minus 8mu. But I mean, what's it equal to on the right-hand side? Plus 4my. Good. So let's just write that line out that you've got here. Anything that you notice that can be done here? Yeah, you can cancel the m's, and you'll find for PCLM that's always going to happen because each thing is being multiplied by the mass. So actually the m's can be cancelled everywhere, which leaves you with 9u take away 8u, or u, equals 3x plus 4y. You've probably, this process is pretty familiar. The second thing we're going to do is NLR. Good, so E is the speed of separation. What's the speed of separation? It's y minus x. And the speed of approach? Yeah, good, because they're going towards each other. It's as though they're being added. So we get that that's over 5u. So we just need to do a little bit of rearranging here. We'll multiply up by 5u So we get 5EU equals y minus x. You'll notice that I wrote 5EU rather than 5UE, just because we always like to keep things in alphabetical order where possible. And the reason that we have agreed to do that as mathematicians is just so it's like easier to read other people's work. We all should be writing it in that same kind of way. So I've got my two equations that I've got here. I've got this equation and I've got this equation. I might need to do some work before, but if I'm trying to find the speed of q, and the speed of q is y, if I'm trying to find out what y is, what do I need to make the subject if I'm going to substitute in? Good. So because I want to find y, I'm going to make x the subject to do the substituting in. So where is going to be easiest to make x the subject? In this first equation or the second equation? The second equation, because we've just got x sort of by itself. So I'm going to rearrange this second equation. So the x is going to go on that side and the 5EU is going to go on that side. So we get x equals y minus 5EU. Then I'm going to take this equation and I'm going to substitute it in up here. So I get u equals 3y minus 5EU plus 4y. And now we can see we've got an equation that's just in terms of y, e, and u, which is great, because the thing we're trying to show is in terms of e and in terms of u. So all we need to do with this is, what do we need to do with this, Haroon? Any ideas? Anyone, what can I do? What am I actually trying to do with this line that I've got here? Yeah, I'm just trying to find y. So I just need to now solve this equation to find out what y is. So right hand side, what do I need to do on the right hand side here? First, expand. So I'm going to get 3y minus 15EU plus, that's me going ahead, saying what the simplifying bit is going to be. So we get u plus 15EU equals 7y. Yeah, I'm probably not going to divide by 7 just yet. If you look at what the question was saying, the question wanted it to be factorized first. So if I factorize, I get u 1 plus 15e equals 7y. And now all I'm going to do is divide by 7. And the way that they've divided by 7 is they will just do the front term divided by 7. And they wrote it, I think, with 15e plus 1 is equal to y. And that is what it says in the question. Let's just remind ourselves that that's what it says. Yeah, it says u over 7, 15e plus 1. So that was all of part A that we have over here. I'm going to try and use the space on the board a little bit better, so I'm going to come over here and do part B. Now this is the part of the question that becomes quite new. Everything that we've done here so far, PCLM, NLR, simultaneous equations, that's what you did in all of your homework, but everything was pretty much numerical, wasn't it? This time it's just been algebraic. Here's the thing that's the most important part of this question, and it's this sentence here. It says, given that the direction of motion of P is unchanged. Okay, so we're now trying to say that the motion of P is unchanged. The motion of P afterwards is x. Do I know what x is yet? No. So the first thing that you need to do is find what x is equal to. And then I'm going to go back to that highlighted thing and I'm going to try and work out what's happening there. Okay? So first of all, we're going to find out what x is. How could I find out what x is with everything that I've got on the board? Which, is there any particular line that would help me find out x as quickly as possible? Good. This line that I have here, I'm going to use to find out what x is equal to, because we've already got x as the subject. So I'm going to say x equals y. Well, we now know that y is this thing. So x equals y, which is u over 7 15e plus 1 minus 5eu. Any questions on what we've been doing so far? No, it's just that it's just maybe a bit tricky algebra. Well, not tricky algebra, just looks slightly messy, doesn't it? We haven't dealt with that yellow bit yet, but we can't deal with the yellow bit yet because we don't even know what P's speed is. So we're going to find out what its speed is, then we're going to deal with the yellow bit. So all I need to do is just a bit of tidying up on this side. I'm just going to have to just do some multiplying out. So I'm going to have 15 over 7 EU plus u over 7 minus 5 EU. So we get that x is equal to, notice how we've got these EU terms here, they're like terms. So we can do 15 over 7 minus 5. Good, minus 20 over 7. I'm going to start with this one because it's positive. So it's u over 7 minus 20 over 7 EU. All we did there to get the minus 20 over 7 was 15 over 7 minus 5, minus 35. 15 minus 35 over 7 is minus 20 over 7. Why did I write it in this different order? We just don't like starting with negatives. It just doesn't look right to start with negatives. So what should I do now to find out the speed of x? It's basically there. I just want to do something more to it to make it look the same way that the other one looks. Let's compare how they wanted to make this look. Going to put the over 7 on the outside, and look, they've both got a u as well. This is technically an answer, but I want you to be in the habit of knowing that all of these questions always make it look like this. So we'll just factorize out the u over 7. We get u over 7, 1 minus 20e. So now we know what x is. This is still the same thing that we did previously, right? This is just PCLM, NLR, simultaneous equations. Apart from these are not simultaneous equations you can whack on your calculator. These are obviously more complicated algebraically, so you just need to take your time to make sure that you get the right answer to get the next parts correct. So this is the important bit. Given that the direction of motion of P is unchanged. Okay, let's just ignore the fact that it's all this kind of algebra here. How would I know if this value here, what would you know about this value if it was unchanged? What was that, Ishraq? It would be positive, yeah. Remember, if you get a negative value, what does that tell you about the arrow that you drew? It's the wrong way around. So here, we've drawn it unchanged, which means we want it to remain unchanged, which means we want the speed, x, to be a positive number. If x is greater than 0, then we drew the arrow correctly, i.e. it remains unchanged, its direction remains unchanged. That's the important thing in this question that most people can get tripped up on. They think, I don't know what to do with this. I found out what x is. All you now need to do is make it greater than 0. So you get u over 7, 1 minus 20e is greater than 0. And it's asking us to find the range, which means inequality symbols, of possible values of e. So this is great here. We've already got the inequality bit. We now just want to find out what's going to happen with e. So here, I could multiply both sides by 7. That would go. I could also then divide by u, because that would go, and we know that u is a positive number, so we don't have to worry about it flipping around. So all I really get left with is 1 minus 20e. This is the thing I'm interested in. Must be greater than 0, which means that we have this. So e must be less than 1 over 20. Good. Ishraq just said, but it has to be greater than or equal to 0 as well. So actually, I think it has to be greater than 0 but less than 1 over 20. It can't be equal to 0, because if it was equal to 0, then it would have, would it have stopped? E can be 0 if they just, no, it can't be equal to 0. I don't think it can. I'll think about that. I might come back to that in a second. No, because if E was, equal to 0, yeah, that would work. Because if E was equal to 0, you would just have the speed of x would be u over 7, and if u over 7 would mean that the speed hadn't been changed as well. So yeah, it can be equal to 0 in this case. It can't be equal to 1 over 20, because if E was equal to 1 over 20, what would this thing here be equal to? It would be 0, which would tell you that the speed of x was 0, which would tell you that what was happening to it afterwards? It stopped moving. And the question says, find the range of values for x where its direction is unchanged. If it's not moving anymore, then we can't say it's got any direction at all if it stopped moving. Okay, so we're nearly there with this question. Let's just scroll up so I can see what part C says. Part C, I'm going to move this as well so we can try and get this all done on one page. I'm not very good at organising my space on the board here, so apologies for this kind of going like in all different locations. We're now going to have a look at part C. It says, given that the magnitude of the impulse of P on Q is 80 mu over 9, find the value of E. So we can either look at either of them, because we know the impulses are actually going to be equal to each other. But P on Q, which side are we actually looking on for the impulse, the right or the left? Yeah, the right side. It's the impulse that P is doing on Q. So there's our impulse. We could also look at this one if we wanted to. I'm preferring to look at this one because of the fact that they already told me what y was in the question. They told you the speed of Q, but we might have got this wrong. Maybe we made a mistake. I definitely know what y is because I did that bit correctly. So I'm going to concentrate on that right-hand side. I might draw the diagram over here so that we can see it. Again, we've got the impulse, we've got this is 2u, and the speed to the right is y, which is u over 7, 15e plus 1. And we want to work out the impulse. Well, they've told you that the impulse, which is 80 mu over 9, and that will be equal to, if we remind ourselves, I is m v minus u. So the m is 4m, so that's 4m. Now it's v, which direction are we taking as positive? Yeah, we're going to take this direction as our positive direction. So it's going to be u over 7, 15e plus 1, minus 2u. Okay, looks like there's going to be some things that can cancel. Anything you can cancel straight away? Pardon? We can cancel the u, but it's a bit tricky to see that you've got a u here and a u here and a u here. It's kind of hard to see that you can cancel the u, but it'll be clearer to see in a second. Is there anything very clearly that can be cancelled? The m can be cancelled. The m can be cancelled like that. Is there anything else that can be cancelled that can help me avoid expanding brackets? How could I cancel this 4? If I divide this side by 4, divide the 80 by 4, and I'm just going to do that to save me doing any bracket expanding. So if I cancel that 4, I can cancel the 80 and replace it with a 20. So I've now got, let's do actually a bit of work. I've now got 20 over 9u equals this thing in the brackets that we have here. So when I expand that, I get 15 over 7 eu plus u over 7 plus 2u. Now you can see that it's really easy to cancel the u's out because the u's are just everywhere. So we can cancel this u, this u, this u, and this u. So we've got 20 over 9 minus 1 over 7 minus 2 equals 15 over 7e. Now is probably the time we're actually going to want to use a calculator and just make life a bit easy. So we've got 20 over 9 minus 1 over 7 minus 2. So that's 5 over 63 equals 15 over 7e. Let's multiply by 7 and divide by 15, and we get that e, I'm hoping you've got this as well, that e is equal to 1 over 27. One over 27, is that bigger than 1 over 20 or smaller than 1 over 20? Smaller than 1 over 20, so it fits inside our range of values that we've got here, which is nice. Okay, so let's just recap on the most important parts of this question. This bit from here all the way down to here technically is stuff that you already knew how to do. The new thing was that if x is bigger than 0, then the arrow was drawn correctly, so it was in the right direction. We were able to ignore the u over 7 and just deal with the inequality that was about the e part that we had here, which gave us the range of values of e. We got this 0 because we know that e is between 0 and 1. When we came back for this bit, again, this is stuff that you know how to do. It's just an impulse. What looks harder about this entire question, like overall though, do you think? It's just, yeah, there's e's, u's, and m's. There's loads of fractions. So my advice to you when you're doing these questions is to take it easy, and to just be really, really careful. Noticing that the structure of what your answer looks like is always this kind of some sort of u or x or whatever it is over 7, not over 7, over some kind of fraction, and there's always an e term and a constant term. Like 99% of your questions are going to take this format. So you always want to be familiar with that. I wanted you to know that's what it's going to look like. Okay. And then we're just going to have a look at a few things that might help you with some of these questions. And then I think most of the lesson is just going to be practice on this. Okay. If you ever run out of space on your pages and stuff, you can always obviously just put it in your notes, or you can write them up afterwards as well. But these are quite big questions. In an exam, this would probably be like the last question in the exam because it's a bit more like weighty. So the last things I just wanted to talk about before we sort of do some practice is some of these inequalities bits. So we've talked about some of these things just now, and it says harder questions often ask for an inequality, and it sometimes is tricky to know where to start, and there are 4 common starting points. So the first starting point is the one that we've just talked about. You know the bit I highlighted in yellow and I said that's the important thing. The direction of a particle is unchanged. So this one is what's talking about the direction of the particle is unchanged. They've got them as V1 and V2. It says, given that the direction of the 3 kilogram particle is unchanged, find the range of possible values of E. Well, what would be the inequality that we would be saying here? What would be the starting point, like where we previously said x is greater than 0? What would we say for this one? No, we don't. No, we don't know about that. What would we say about the 3 kilogram particle? Good. V2 is greater than 0. Did I put my little box with this one? I thought I did. I thought I had like a hidden box for it. So V2 is greater than 0. Let's just write that one in that we've got there. So V2, why have I written V squared then? V2 is greater than 0. The second scenario is where you just start off by saying that E can be between 0 and 1. So if it says find the range of possible values of K in this scenario, we don't know anything at all about the directions, so that doesn't matter. The only thing we will use is this fact that 0 and 1 are the range of things that E can be, and that will make a bit more sense when we try a question in just a second. The third thing I've said here, part C, is collision logic. Having a look at what we've got written here, is there anything that you think, if we're going to try and find out anything about E, what do we know about the speeds at the bottom and the speeds at the top? For just being sort of like sensible and logical. V2 has got to be less than what? No, it's got to be less than 4, because after a collision, it can't make sense for this one to be going faster than this one if they're going in the same direction. So we could say that V2 is less than 4. What could we also say about U2? U2 has got to be greater than 2, otherwise it would never catch up. Okay. I also think V2 could probably be equal to 4, because it could be like those questions we've done where they, does anybody remember that word? When they're stuck together and there was a special word for that, began with a C. Coalesce, or common speed, yeah, but coalesce. If the particles coalesce, it could be equal to that. And then part D, there's another thing about talking about the particles colliding again. It won't work with 2 of them, but if you have 3 particles, there are going to be some conditions that we can add in that will say, for there to be another collision, what might be the setup? So all these questions that I've got set for you on the previous page, you're going to have a think about possibly some of these scenarios to do that last bit as well. Okay, so I'll put those questions up for you and we'll go from there.